The physical properties of matter. Physical properties. They're going to be things that you can see, hear, smell, taste, touch. Those are the physical properties. A green shirt, a blue shirt, silver shoes, whatever it might be. Soft texture, rough texture, physical properties. Every type of matter has two kinds of properties. It can be physical and chemical. A physical property is a characteristic that can be observed without changing the substance into a new one. You're just simply changing the way it looks or how it feels, but it's still the same thing. Gunnar, you can just follow along with me up here, or you can look on your slides on yourself. It's whichever you prefer. Physical properties. This is important. You need to know these. Hardness, texture, density, flexibility, color, the ability to dissolve, magnetism, melting point, boiling point, and the substance physical state, whether it is a solid, liquid, or a gas. It always does. I don't know why. It's never been just quite right. All right, physical properties. Who can give me a physical property of this brick wall? Anybody, out loud. Go ahead.
Bricks.
No.
Solid.
Solid, I'll take. Anybody out loud?
Smooth.
Rough.
Smooth and rough.
See how pins putting?
Bumpy.
Rocky, okay.
Red.
Red, good.
Stacked.
Say it again.
Stacked.
Stacked.
Is that a tree?
Hard.
Is that a tree?
Hard.
Hard, good. Yeah, he's saying it's stacked on top of each other, so that would be like the pattern.
Brick.
It is brick, yeah, I guess that's kind of a given. Now, it's definitely not flexible. Color,
Very dense.
will it dissolve?
No.
Not easily. Probably it's not going to have any effect on them with a magnet. Melting point, I mean, it would eventually melt, but it's going to have a really high melting point. Boiling, no, you can't make brick boil. And then we said it's a solid. So I think that's a pretty good, and you don't have to write these down, we're just doing these out loud together. Using physical properties to identify a substance. Some physical properties of substances are unique. Therefore, their properties can be used to determine mystery objects. Some things, if they just fit into a certain physical category, we can automatically identify what they are just based on that. Imagine if someone wanted to sell you this gold coin. It might be a real gold coin, it might not be, but we just know it's gold. You can use the unknown physical properties in order to test. What is one way we could test this coin to determine if it's really gold or not?
Bend it.
Maybe. Because sometimes, you got those plastic ones that you might get like at a carnival or something. Okay. If we could bend it easily or break it, we know it's not real gold.
You can actually
Taste.
I don't know that fake gold and real gold would have a different taste. I don't know. JR, what do you think?
I'm pretty sure gold is actually it may be heavy, but it's actually kind of weak, and we could actually take a good
So we could test the
and
what?
then we could, take
But what would we need to test?
mass.
The mass is going to be a very big hint. Very good. Gunnar, what else could we do?
Minerals and that goes into a streak test.
Wonderful, wonderful, Gunnar. Yes, they do. We could actually take this, if we had this gold coin, and it kind of looks like a piece of white chalk would look like, and you actually could take that coin and slide it across this plate, and it would actually make a true color. If it is almost like no color. But if it's fake gold, it's going to make kind of like a brownish, kind of grayish streak. So there is a hardness test that would tell us for certain if it was real gold, or sometimes it's called fool's gold. Does anybody know what fool's gold's really called? It's called pyrite, is what fake gold is. Yes. Elements of the same group are sometimes said to be in the same family. Oh yeah, my marker's really not performing well today. It is not liking it. This is because elements that are grouped together often have similar properties. this particular periodic table, they've color coded it, okay? So if it's like kind of this reddish color, it's a non-metal. Orange, an alkali metal. Blue is alkaline earth metals. Green are transition metals. Kind of this kind of yellowish orange is other metals. Light blue, metalloids. Kind of the purplish are halogens, and then the dark blue are noble gases. Again, all periodic tables are going to have different colors, and that's fine as long as you look at the key and you know what that color stands for. Like this one back here is, you know, green, blue, yellow, pink, and like an orange. Look around the room. How many objects do you see that are made of metal? What do we see? Filing cabinet, good.
Chair.
The legs of your chair, good. That filing cabinet back there.
The
The cart. The hinges on the door and the hinge across the top of the door, good.
The keyboard.
Yes, the refrigerator is, yes. My middle stool, okay. We're good.
Parts of your PC.
So tell me then, what are some physical properties of metal? We've identified a bunch of them. What are some physical properties?
Tough, solid,
Okay, so solid I'll go with for sure.
able to withstand very high temperatures.
High melting point. Good one. What else?
They can have a very large or light mass.
Well, different mass, okay. Is it going to be, is all metal shiny? No, but it may have a certain, you know, could be shiny, could be dull. Could be smooth, could be rough. Whoops, if I can spell.
Could have chips in it.
Maybe easily bent, we could say, okay.
Gold is in a gold coin. Then,
No.
Okay. Metals that are malleable.
what's that?
That means you can hammer it into a flat sheet. Like a tin roof, you know how tin, you can actually hammer it out and you can flatten it. Gold can do the same thing. You can also, some are attracted to metal, or some metals are attracted to magnets. Metals are ductile. Ductile means they can be pulled out into wire. Copper wire, okay? When you're stretching out that copper wire, what you're really doing is lining up electrons. As you line up those electrons, you can draw that wire out. When you're hammering out those sheets to make like your tin roof, you are taking those electrons and you're flattening them out. Yes?
So, you know how magnets are attracted to copper?
Correct.
Well, if you drop a magnet down a copper tube, it will actually slow down, and that's because some of the energy of it falling
The electrons, yes.
down goes into the copper, creating an electrical current, and electrical currents are known to make a magnetic field.
They are. Very good, very good. Most metals are good conductors of heat, so your skillets at home are almost all metal. Your like a saucepan, if you're going to cook on the stove, it's made of metal. Families, let me check my, okay, 66, where did I say? 8, okay, we've got quite a bit. We probably won't get this far enough, but that's okay. Use the link below to print blank copies. Okay, we don't have to do that, that's fine. Alkali metals versus alkaline earth metals. Let me see how much time. Okay, we've got about 5 minutes. Elements that are found in group 1, which is going to be the first column on the periodic table. Elements that are found in group 1 are called alkali metals. This is group 1. Elements in group 2, so this is group 2, which is the second column, are called alkaline earth metals. Not only are their names similar, but their properties are as well. Anything, if you look at your periodic table, anything in the first 2 columns are going to be highly reactive. So what does it mean when they're highly reactive? What do they want to do? Go ahead.
be with other elements.
They want to join with other elements so they will be stable. What did I tell you about the very last column? The very first two are very reactive, so what's the last one?
It's still gonna be very
It's very stable. They do not want to join with any other elements. They are fine by themselves. They're called the noble gases. They don't need anyone else. They like to stay by themselves. The first two, always in nature, will find another element to pair up with and make a compound.
The social butterflies.
There you go. There you go. And so these react by losing one electron. They're never found uncombined in nature. The most reactive, sodium and potassium are the most important alkali metals. Then group 2, they react by losing 2 electrons. They're never found uncombined in nature. They are the second most reactive. And then magnesium, calcium are the most important. We will be looking more at how elements react with each other in the unit 2. Does malleable mean that a metal can be hammered into a flat sheet? Yes or no? Yes, it does. Alkali metals react with other elements by gaining one electron.